far we have done, that is, we have two kinds of physical quantities. One is scalar physical quantities, the other is vector physical quantities. Scalar physical quantities, they have only magnitude. Magnitude is the bigness of a quantity. Like we say, distance of 5 meter, 10 meter, 16 meter, mass of 5 kg, 6 kg, 8 kg, 5, 6, 8, etc. That is the magnitude, the bigness of a quantity. And the quantities like distance, mass, time, etc., they are the scalar quantities. When we say mass, it doesn't make any sense if we say that is mass is 5 kg towards east. That doesn't make any sense. And on the other hand, we have physical quantities which have magnitude also and which have a direction also. We have a speed of 5 meter per second towards east, so that makes it velocity. The magnitude of velocity is speed, that is 5 meter per second, and when we add direction to it, that is towards east, so this is a velocity of 5 meter per second which has a direction also. So when we talk about the vectors, they are those physical quantities which have got magnitude also and which have got direction also. Apart from this, though, when we talk about the scalar quantities, they can be algebraically added. Like a volume of 5 liter plus volume of 3 liter is going to make total volume of 8 liters. So these scalar quantities, they can be algebraically added or subtracted. Whereas when we talk about the vector quantities, because they have a direction also, so they cannot be directly, simply algebraically added or subtracted. They are added, subtracted by geometrical ways because they have a direction also. So when we talk the vector quantities, they have magnitude, they have direction. Apart from this, their addition, subtraction, etc., that is governed by vector algebra principles and not by simple algebraic operations. Using vectors, we can precisely and concisely pass on the information. Like if we say this is y-axis and over here this is x-axis, this is y-axis, this is x dash, this is y dash, and this side is, we say this is east and this is west. Similarly over here north and south. A person goes from here to here 5 meter. So we'll say the person has gone 5 meter towards east, whereas using vectors, we'll say the displacement of this person is 5 cap meter. If the person has gone this way 7 meter, we'll say the displacement of this person is 7 cap meter. If the person has gone 7 meter this way, we'll say the displacement of this person is minus 7 cap. If the person has gone in this direction along the negative x-axis, so we'll say the displacement of this person is minus 5 cap. Whether the person has gone from here to here in this quadrant or even the person has gone this way 5 meter in this direction along the negative x-axis, the displacement of this is still all going to be 5 cap meter. If the person has gone in the upward direction, we have unit vectors as j cap. In the downward direction we have minus j cap, in this direction we have plus I cap, and in this direction we have minus I cap as a unit vectors. Like over here we have x-axis, y-axis and z-axis which are mutually perpendicular to each other. Similarly, we have unit vectors along x-axis, along y-axis and along z-axis also. Along the positive x-axis, we have unit vector as I cap. Along the y-axis, we have j cap, and along the z-axis, we have unit vector as k cap. If the person has gone this way along towards east 5 meter, whether he has gone in this quadrant or in this quadrant or in this quadrant or this quadrant, anyway it has gone, so we'll say his displacement is plus 5 I cap. If the person has gone in this direction in any of the quadrants, if he has moved in this direction it is minus I cap, we'll say his displacement is minus 5 I cap and we'll put the units. If instead of this displacement we have a force which is being applied in this direction as 5 Newton, so we'll say the force is minus 5 cap Newton. The units, they will change. Rest is the basic principles, they will remain same. As we have x-axis, as we have negative x-axis, as we have y-axis, as we have negative y-axis, similarly we have a unit vector. Unit vector means it has a magnitude of 1 and it also has a direction also. I cap is in this direction and its value is 1 only. 1 meter, 1 Newton, it could be any units depending on the physical quantity we are talking about. If the vector is aligned along the positive x-axis, we will say the unit vector is j cap. If it is in the downward direction, we will say minus j cap. If it is in the upward direction, we will say plus k cap, and in the downward direction is minus k cap. So unit vector is, let's say, I cap, j cap or k cap. This is also called cap, caret or hat. Anything you can use. So now if someone says a force of 10 I cap Newton is applied, so you very well know the force is applied in which direction. It means the force is applied in this direction of magnitude 10 Newton, and from I cap you have deducted that this force must be in the positive x-axis, and the unit of this is Newton only. If someone says a force is applied minus 5 j cap, it means we know I is in this direction, I cap, this way it is minus I cap, this way unit vector is j cap, and this way it is minus j cap. So if someone says a force of minus 5j Newton is applied, it means the force is applied in this direction, downward direction, and its value is 5 Newton. So this gives the direction and this gives the magnitude, that is how big is the physical quantity. So far we have been doing when the forces or vectors or displacements, they are aligned purely along x-axis or y-axis or even z-axis also. If a body purely goes in this direction as 10 meter, so we'll say its displacement is 10 k cap plus meter, 10 k cap meter. And if a bullet goes like this piercing through this board and it goes 7 meter below this surface, so we'll say its displacement is minus 7 k cap meter. So from here we can very well understand that is I cap, j cap and k cap, they are the unit vectors along the x-axis, y-axis and z-axis. Similarly, we have minus I cap, we have minus j cap and minus k cap along the negative x-axis, y-axis and negative z-axis. So far we have done all the cases where the displacements or the force or all the vectors, they are aligned purely along the x-axis, y-axis or z-axis. What if a vector is not aligned purely along x-axis, y-axis or z-axis, but it is at some angle, let's say this way, it is this way, we apply a force of 7 Newton in this direction at angle of 45 degree. So now how we will represent it in vector notation. When we represent a quantity in vector notation, so it means from this vector notation we can take out the magnitude also and we can take out the direction also. Like when we say it is 5 I cap, this is vector, and let's say this is a force of Newton or displacement or anything, this is velocity also, velocity is also vector quantity, acceleration is vector quantity. So when it is 5 I cap Newton, so from here we can take both the things, that is magnitude is 5 Newton and I cap is the direction in this direction. So we have taken out both the things, it has got magnitude also, it has got direction also. It is not a scalar quantity. When we talk about scalars, they are just number 5, 7, 8, minus 5, 3 or so. But when we talk the vector quantities and the representation is vector, we have to have both the things. We have to have magnitude also, we have to have the direction also. When we represent it this way, so it has got magnitude also, this got direction also, and this is vector notation. When a body has gone from here to here, or let's say a force is applied 7 Newton, making an angle of 45 degree with the positive x-axis in the upward direction or anti-clockwise direction, so this is magnitude and this is direction. Is it possible to represent this force being applied at this angle in this vector notation, that is I cap, j cap, z, k cap or so? Yes, it is. We have to understand that is how the vectors they are added. That is the first thing we shall be doing, that is how to add the vectors, and then we shall be talking about the resultant of the vectors, and we shall also be understanding that is how to break a vector into its components, that is how to resolve a vector. When we say to find a resultant, that is also called composition of vectors. So we shall be doing few of these simple things. They are very basic and very interesting things, though vectors lies under the purview of mathematics primarily. So let's understand the addition of vectors first.